Hi, this is Saeed Yahya, and I'm working for Internail. Internail is um, an Egyptian company located in Cairo, and we are partnering with Red Hat to provide solution to the area. And our biggest achievement is the reward of a contract with the health ministry in Egypt to build their websites and their web applications. The solution we are providing is for Dubai Holding Challenge. And the challenge is to deploy digital solutions across several business units, hospitality, food and beverage, real estates. And the deployment should have some specific characteristics, the reduction of paperwork and the need for human intervention, and the increase of transaction speeds, and the increase of customer engagement. The way we are achieving these goals of this challenge is based on work done by an interest group in Red Hat called the Interest Group for Emerging Technology. And the work of this group is based on our forecast for the future. Our forecast is that microservices will be the futures, and applications for the future will be data driven. And these data driven applications will need specific architecture. And at the end of this presentation, we will put together the solution we are presenting for Dubai Holding Challenge. So first, the microservices. Microservices is the idea of dividing the monolithic application, this huge application requiring lots of resources, into smaller elements called microservices. Every microservice can do just one function and can also give the application specific attributes like transaction speed. So if, for example, we want to increase the transaction speed, maybe we can do that by scaling up the front end of the application. And this is achievable by the microservice. The microservice also allow us to allocate specific resources, human resources, developer, system administrator to the microservice. Also, the microservice allow us to scale up when the resource when more resources are needed, and to scale down when the resources are not needed. So it's the achievement of the goal in the most economic way. If we talk about the data-driven application, maybe one of the best examples is Amazon. One of the feature of Amazon as a retail digital solution is the recommendation of items, related items, or items purchased by other persons when the user is looking for a specific item. And obviously, this type of recommendation is based on the analysis and the archive of historic data, of huge amount of historic data, so that the recommendation can be correct, can convince the user to make more purchase. Another example of data-driven application is Uber. Uber is having a fantastic feature, which is the recommendation of the correct rate for the trip. A rate which is accepted by the supplier, the taxi driver, and the consumer, the person who is transportation. This rate is also calculated by Uber by processing a huge amount of data. Data about the supply, the number of taxis in this route, the demand, the number of person person's needs, the condition of the road, lots of other data. And these modern successful application today. So specific responsibilities. Actually, they have the normal responsibilities of all other application, whatever the processing is for financial transactions, logistic transaction, whatever. But they have also some additional responsibilities. And these responsibilities are related to data. And data can be events, can be databases, structured record, can be unstructured data like files, like objects, storage, and so on. So data-driven application have the ability to transform these events so that they can be aggregated. And the aggregated data can be trained to make to make a model, a predictive model, a model which can feed again the transformation of the events, the structured records, the unstructured records, to aggregate them again in a better way, to train the model in a better way. So this cycle is a continuous cycle, and also it should be a very efficient cycle, so that these data, which are the actual transaction of the user of the application, can have the proper response, like the proper recommendation or the proper rate from the application. It's also clear that one of the responsibility of this application is that the archiving of the data, and the archive are the raw data, the events, the structured records, the unstructured records. These are the raw data, the source of truth, and the archiving of this raw data allow the data-driven application to reprocess the history, so that they can rebuild the model if we discover better way for recommendation, or better way for calculating rates, or better way to achieve the functionality needed by the application. Beside that, the interfaces, web and mobile, a reporting interface for the business, and the developer user interface, which are concerned with the predictive model to develop and to enhance the development model, and the management, which is the deployment of the data-driven application. And as we said, the deployment of data-driven application are mostly microservices, and they need specific a way to achieve the characteristic needed, from speed to interaction to increase efficiency, and so on. Actually, the data-driven application existing right now, they have a solution which is normally a conventional data warehouse solution. And this solution is can be described as follows. There is a part for transaction processing. The user with the transaction supply data, and this data is processed by some business logic, and the transaction is stored in a relational database management system. And this database is optimized for updates, and for inserts, and for deletes. And this database is then dumped into another database, which is used for analytic processing. So it is optimized for reporting and optimized for querying, and also, of course, optimized for analysis. Analysis can feed back the business logic, so better data, better transactions data are stored in the transaction database. This conventional data drawback, and the most obvious one is that the historical data cannot be reprocessed easily. If we find a better way to do analysis, and we find that the structure of the transaction database does not allow us to execute those better analysis, we are faced with a restriction to implement the better analysis we have discovered. Other architecture are proposed to resolve this restriction. And one of them is the Kappa architecture, which is composed of several messages queue. So here the events or whatever data are queued in queues, and these events are the source of truth. They are the raw data, and they remain in the queue, and they are processed with different processing. So like transformation, and then the transformation put the pre-processed data into another queue, and these pre-processed data are analyzed, and the analysis results are put in another queue, and so on. And then the interface for reporting and end user exists. And this architecture has been implemented in the Fedora infrastructure. Fedora is one of the upstream of Red Hat, and it's composed of thousands of applications, thousands of activities, thousands of groups. So it's a huge community. Software control management packages, for example, the Wikipedia, the media Wikipedia packages, all of these application feed messages into the Fedora message bus. The meeting tool application is recording the meeting, for example, as messages in the Fedora message bus. Koji is the building utility for Fedora, and all the messages resulted from building the application daily or weekly or whatever. All the resulting messages are also fed into Fedora messages bus. So the messages from different sources are gathered and accumulated and federated in the bus, and then interfaces serving different purposes, like command line interface tool or notification. All of these interface serve the users from the message bus. So this way, the source of truth, the raw data, are kept as they are, and we have the opportunity to reprocess this source of the source of truth, this raw data, and have better analysis, a better usability of this data to the different users. Now, the data-driven application have a specific compute layer. Compute layer is concerned with the transformation of the raw data, the aggregation of this raw data, the training of the predictive model. This is the compute layer, which is specific to data-driven application, and which is additional layer added to the conventional application functionality. And this compute layer is satisfied and implemented by a specific system, and as well as the other part of the solution we are providing. In the next slide, we will try to propose different part of the solution, and all of these parts are open source projects. All the solution we are proposing is based on open source. Red Hat is an open source company, and the solution, the heart of the solution is really to integrate those different projects so that we can satisfy and meet the requirements of the challenge. So Apache Spark is the open source project which is responsible of the compute layer, which is responsible of the transformation and the aggregation of and the archiving of the raw data. Message queue is the project which is responsible for events handling. Java data virtualization is the part responsible for the database record. Gluster and Ceph is a part used for managing unstructured data, and so on. So these open source projects compose the solution we are proposing to fulfill the requirements of Dubai Holding Challenge. We hope that the solution satisfy your requirements, and thank you.